Hi everyone, Assalamualaikum. In this video, we are going to discuss topic 3 in applications of definite integral, which is volume by washers. The dis and washer methods are specialized tools for finding volumes of certain kinds of solid, which is solid of revolution. Alright, now suppose the generating region here is bounded by two curves, okay, which is y equals to fx on the top and y equals to gx on the bottom. Alright, this time when you revolve this region around an axis, let's say our axis of rotation is a horizontal line here. This is rotation symbol, okay. Alright, when you revolve this region around an axis, the slice perpendicular to that axis will look like washers, right? Alright, y equals to fx on the top here, now is called outer curve, okay? And y equals to gx on the bottom here is called inner curve, right? Alright, after the rotation, okay, after the shaded region here is revolved about this line, okay, we will get this diagram, okay. This is axis of rotation, right? And since the axis of rotation is a horizontal line, so the equation of this line is y equals to k. K here means constant, right? From the shaded region here, okay, there is a gap between the shaded region and the axis of rotation. Okay, here is a gap, right? So, after rotation, we will get hollow here, okay? A washer is like a disc, but with a center hole cut out here, right? Right, this is the diagram before rotation. And this is the diagram after rotation. Alright? This is y equals to fx, which is outer curve. Okay? And this is y equals to gx, okay, which is inner curve. Alright? In this diagram, we not use term top and bottom because after rotation, the outer here y equals to fx, which is the top function, will change to the bottom function. So that's why for volume by washer, we use outer radius and inner radius. I mean outer curve and inner curve. Okay, not top curve and bottom curve. Alright? Alright, the formula for the volume of a washer requires both R1 and R2, right? Where R1 equals to the outer radius and R2 equals to the inner radius, right? Then we can set up the formula of volume by washer, okay? Alright, volume by washer equals to pi integration from x equals to a to x equals to b, okay, dx, okay, outer radius squared minus inner radius squared, okay, and all of this must in terms of variable x, okay, and since we want variable x, so we need to write y as a subject, okay, if the axis of rotation is a horizontal line, okay. Horizontal line here means x-axis or parallel to x-axis. Okay, I repeat, when axis of rotation is a horizontal line here, okay, so when we use washer method, okay, we will integrate with respect to x. And when we integrate with respect to x, we need to use lower and upper limit on x-axis, right? And when we integrate with respect to x, we need to write all the function here in terms of variable x, okay? And to write in terms of variable x, we need to write y as a subject, right? Right, this is the formula for volume by washer if axis of rotation is a horizontal line. Okay. Alright, outer radius, okay, means outer curve here minus axis of rotation, the distance between outer curve and axis of rotation. Inner radius equals to inner curve here, okay, minus axis of rotation, which is R1 here, okay. Alright, now we consider this diagram, okay. From this diagram, we have two curves, okay. Alright, and then we have axis of rotation is a vertical line, okay. And from the shaded region here, okay, the shaded region here is bounded by outer curve x equals to Fy and x equals to Gy, which is inner curve, okay. Alright, after rotation, okay, after this shaded region is revolved about this line, which is vertical line, so we will get this diagram, okay. This is axis of rotation, right? Alright, since this is vertical line, our axis of rotation now is a vertical line, so the equation of axis of rotation is line x equals to k. K here means constant, right? And from the shaded region here, okay, there is a gap between the shaded region and the axis of rotation. Okay, this is the gap, right? So after rotation, we will get hollow here, right? A washer is like a disc, but with a center hole cut out here, right? Alright, this is the diagram before rotation. Okay, and this is the diagram after rotation, right? Alright, from here, the right curve here, okay, this is called outer curve, okay? And from the left curve here, this is called inner curve, right? Alright, under volume by washer, we not use top curve, I mean right curve and left curve, okay? But we use outer curve and inner curve because after rotation, if we use right curve here, okay, so after rotation, the curve will here, okay? And now we can see that when we compare from both curve here, x equals to Fy here now on the left. So that's why for volume by washer, we use term outer curve and inner curve, right? Alright, the formula for volume of a washer requires an inner radius and outer radius, okay? Alright, R1 here means outer radius, okay? And R2 here means inner radius, alright? Alright, then we can set up volume by washer's formula. Okay. Washer formula equals to volume by washer equals to pi, and then integrate from y equals to c to y equals to d, and then outer radius squared minus inner radius squared dy. Right? Alright, if we integrate with respect to y, we need to use limit on y axis. Okay, and all must in terms of variable y. Okay, and to write in terms of variable y, we need to write x here as a subject. Okay, so this formula is for axis of rotation is a vertical line, right? Vertical line means y-axis or parallel to y-axis, right? Right, I repeat, when axis of rotation is a vertical line or parallel to y-axis, so using volume by washer, okay, we need to integrate with respect to y. And when we integrate with respect to y, we need to use lower limit and upper limit on y-axis. And at the same time, we need to write in terms of variable y. And to write in terms of variable y, we need to write x as a subject. Alright? Alright, from this formula, outer radius equals to outer curve minus axis of rotation. The modular sign here means we take a distance. Okay. Alright, and then inner radius equals to modulus inner curve here. Okay. Minus axis of rotation. Alright. Alright, now we look at example 1 from the previous semester papers. The figure below shows the region R bounded by the curve y equals to 2 times x minus 3 squared here. Okay. And y equals to 2x minus 2 here. Okay. Use the washer method to find the volume of the solid obtained when the region R is revolved about the x-axis. Okay. Alright, from the given question here, the axis of rotation is x-axis here. Okay. Right. From volume by washer formula, okay, if axis of rotation is a horizontal line, okay, x-axis means horizontal line, so we need to use all in terms of variable x. And to use variable x, we need to write y as a subject. Alright, so now we are given y as a subject. Okay. Alright, after rotation, we get this diagram. Okay, y equals to 0 here means x-axis. Okay, this is outer curve and this is inner curve. Okay, alright, from the given diagram here, okay, there is a gap between the shaded region here and the axis of rotation here. Here is a gap, right? So, after the shaded region here is rotate about this line, okay, which is x-axis. So we will get hollow here, okay, alright. Okay, a washer is like a disc, but with a center hole cut out, okay. Here is a hollow, okay. Alright. So this is axis of rotation, y equals to 0, which is x-axis. Okay. This is outer curve here or outer line. Okay. This is inner curve or inner curve here. Okay. Alright, this is outer radius R1. Okay, this is inner radius R2. Okay, from here, okay, we can refer the cross section of the diagram here. Okay, from the dotted line here, this is a hole. Okay, this is outer curve or line. This is inner curve. Right? And then when we draw a line to x-axis from the intersection point here, okay, x equals to 2 and x equals to 5. Alright? Then we can set up formula volume by washer. Okay, outer radius equals to modulus outer curve or line minus axis of rotation. Okay, so outer radius equals to, we replace outer curve by 2x minus 2. Okay, outer curve or line. And then minus, okay, axis of rotation, here we replace by 0. Here, okay. Alright, from here we can see that y as a subject. That's why we can subtract. Right? Then we simplify, so we get outer radius equals to 2x minus 2. Right? Right, after we find outer radius, we need to find inner radius. Okay? Inner radius equals to modulus inner curve or line minus axis of rotation. Right? So, our inner radius equals to, we replace inner curve or line equals to 2 times x minus 3 squared. Okay? And then we have minus sign here. And for axis of rotation, here we replace by 0. Right? All from this equation, y as a subject. Okay, that's why we can subtract. Alright? Okay, then we simplify, so we get inner radius equals to 2 and then times bracket x minus cube squared. Alright? So this is our outer curve, outer radius, and this is our inner radius. Right? Alright, from the previous slide, we get outer radius equals to 2x minus 2 and inner radius equals to 2 times x minus 3 bracket squared. And this is the cross section of this diagram. Alright? Alright, from volume by washer equals to pi integration of outer radius squared minus inner radius squared. Okay, we squared first, then we minus. Okay, not outer radius and then minus inner radius and then is in the same bracket squared. Okay, but we separate the squared. Alright, so from this formula, okay, if axis of rotation is horizontal line, okay, from here, this is our axis of rotation. So we need to integrate with respect to x. Okay, when we integrate with respect to x, we need to use lower limit and upper limit on x-axis. Okay, so from this diagram and this diagram, okay, x is from 2 to 5. Okay, so 2 here means our lower limit and x equals to 5 is our upper limit. Right? Alright, then volume by washer equals to pi integration from 2 to 5 and then outer radius, okay, is 2x minus 2 and then bracket squared minus inner radius is 2 times x minus 3 bracket squared. And from the given formula here, we need squared outside here. Okay. Alright, from washer method, okay, and this method, okay, if axis of rotation is parallel to x-axis, okay, So we need to write all in terms of variable x, okay, including lower limit and upper limit, okay, must on x-axis. Alright. Alright, so from here, outer radius equals to 2x minus 2 and inner radius equals to 2x minus 3 bracket squared. Okay. And after that, we need to expand and simplify. Okay. So we have washer, volume by washer equals to pi. Okay. And then integration from 2 to 5. When we expand here, so we get 4x squared minus 8x plus 4. And then minus 2 squared equals to 4. And then x minus 3 bracket squared equals to x minus 3 bracket to the power of 4. Okay. Alright, after that, we need to integrate with respect to x. Okay. Alright, for x minus 3 bracket to the power of 4 here, we no need to expand. Okay. Because we can integrate using u substitution. Alright. Alright, to integrate 4x squared, we can use power rule. And same goes to x8. Okay. And to integrate x minus 3 to the power of 4, okay, 4 here means not equals to negative 1. So we can use this formula if u means in bracket here, is a linear function ax plus b. In this case, our a equals to 1 and our b equals to negative 3. Okay, so if we have linear and then to the power of any value except negative 1, we can use this formula. 1 over a means coefficient of x, means 1 over 1. And then times linear, okay, and then 4 plus 1 and then over 4 plus 1, okay. Or we can use u substitution, u equals to x minus 3, okay. So from here, after we integrate, so we get pi and then square bracket, we still have 4 here and then we integrate x squared using power rule. So we get x cubed over 3 and then minus 8 and then x squared over 2. Over 2 here, we can simplify with 8. That's why we get 4x squared. Okay. And then plus, we integrate constant with respect to x, we get 4x. And then we have multiplication by 4 here, so we still have 4 here. And then to integrate x minus 3 to the power of 4 here, we use this formula. So we get linear means x minus 3, and then 4 plus 1 means to the power of 5, and then over n plus 1 means 4 plus 1. That's why we get over 5 here. Right? Alright, after we integrate, no more integration sign. Okay? And then we replace upper limit 5 into variable x. Okay? So we get this. And then in between must minus. Okay? Then we replace lower limit 2 into variable x. Then we get this. Okay? After that, we simplify, so we get volume by washer equals to 288 over 5 pi units cube. Okay, cube here because of the volume here. Alright? Alright, we can check the final answer using symbol lab. Okay? From here, after we set up the formula for volume by washer, okay, we can transfer into symbol lab. Okay? Alright, pi and then integration from 2 to 5 and then 2x minus 2 bracket squared and then minus 2 times x minus 3 bracket squared and then bracket squared dx. Okay, so this is the syntax in symbol lab. Okay, alright, and then we press enter, so we will get 288 pi over 5 here. Okay, and from the final answer here, we can see that volume is a positive value because volume always positive. Alright? If we get volume equals to negative value, we need to double check. Okay, from when we set up the formula and then when we integrate. Okay, and when we replace the values of upper limit and lower limit. Right? From the answer here, okay, we leave the answer in fraction and pi, okay, to get more accurate. Alright? Right, this is the complete answer. Okay, got it? Coming up next, more examples for volume by washers. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.